Hi guys, so we're going to continue with names and formulae of compounds. So this is the periodic table. In the periodic table we have metals, metalloids, and nonmetals. The metals are on the left of the periodic table. The metalloids and the nonmetals are on the right of the periodic table. But we're going to learn about that later. For now, I just want you to admire that this is the periodic table of elements. Names and symbols of elements. So elements are grouped together in the periodic table as you saw on the previous slide. And they form vertical columns called groups. So the columns that go down on the periodic table are groups, and there are 8 main groups. And then we have horizontal rows, which are called periods, and we have 7 periods. The elements are represented in symbols, many of which are derived from the first letter of the Latin or English name. So don't be surprised when you see an element that has a name that doesn't seem to correspond with that has a symbol that doesn't seem to correspond with its name. That is just because many of the symbols are derived from the first letter of the Latin name. So in the symbol, the first letter is always a capital letter and the second one a small letter, as you can see on this table of common elements and their symbols. So the first letter is always a capital letter, and then the small letter is the second letter is always a small one. So you need to know or familiarize yourself with these common elements and their symbols for exam purposes. So you should know that mercury is Hg, you should know that lead is Pb, you should know that platinum is Pt, silicon is Si, tin Sn. You should just familiarize yourself with these elements. So a compound, as we said earlier, is formed when 2 or more elements combine chemically in a constant ratio. And the formula of the chemical compound is a combination of the symbols of the elements making up the compound as well as the ratio in which they combine. So by this we mean that if, let's say, a compound contains 2 hydrogen atoms and 1 oxygen atom, so the formula for that compound will be H2O. The H represents the hydrogen in the compound, and then the 2 next to the H tells us that there are 2 hydrogens in that compound. And then the O tells us that there is an oxygen atom and it's just 1, because we don't write 1 next to an atom if it's just 1 in that compound. So different types of chemical bonds can take place between the atoms. And one such bond is the ionic bond, which we will learn about when we do chemical bonding. So during ionic bonding, an atom can donate an electron and form a cation, which is a positive charge. So remember that your atoms, they are neutral. Neutral meaning that they have the same number of electrons, which are negative charges, and protons, which are positive charges. So if an atom then loses an electron, it means that now it has many protons compared to your electrons. So it does make sense that it becomes positively charged. So it forms a cation. And then when it accepts an electron or gains an electron, it forms an anion, which is a negative charge, which also makes sense because if now you have more electrons than your protons, you are obviously going to be negatively charged. And then oppositely charged ions, they attract via the electrostatic force. We use the group number to determine the ionic charge or the valency of the main group elements. So for group 1 to 3, we determine the valency by just taking the group number. So the valency for groups 1 to 3 is the group number. The valency for all the elements in group 1 is 1, and they form positive ions, which are cations. So they are all positively charged. Group 1 to 3, the valency is 1, 2, and 3 respectively. And then for groups 5 to 7, we determine the valency by taking the group number and minusing 8. So group 5 will have a valency of -3 because 5 minus 8 is -3. And then group 6, they will have the valency of -2 because 6 minus 2 is 6 minus 8, is minus 2. And group 7 as well will have a valency of minus 1 because 7 minus 8 is minus 1. And they will all form anions, which are negative ions. So this is a table of cations. You need to know this table, okay? You need to familiarize yourself with this table. For instance, you need to know that when you get tin, you need to know that tin is a cation. You need to recognize these different cations. Your ammonia, so ammonia is NH4 plus. You need to know that when you're given ammonia, the charge for ammonia is +1. So you need to familiarize yourself with this table for exam purposes. You need to know that manganese, the manganese 7 is a +7. When you're giving iron, you need to know that the iron 3 is a positive ion, is the cation. So you need to familiarize yourself with this table. And this one also, the table of anions. We have so many anions that are not elements. They are compounds, like your nitrates, your nitrites, your hydrogen carbonates, your dichromates, your chromates, thiosulfates, your oxalates, nitride, phosphate, phosphide, acetate. All these things you need to familiarize yourself with because we're still going to use them a lot, especially when we derive formulas for compounds. So how do you write the name if the formula is given? The compound name always includes the names of the elements that are a part of the compound. For example, FeS is going to be named iron sulfide because Fe is iron and S is sulfur. So we have rules in writing the names. Of course, in science, we always have rules. So cations have the same name as the corresponding elements, like your sodium ion, your copper ion, your potassium ion, etc. But in anions, the name of the elements changes to end in IDE. Take the FeS example again. So the sulfur name is changed to sulfide because we know that sulfur is an anion since it's in group 6. So we know that it's going to form an anion. So then the sulfur name will change to sulfide. So we're going to have iron sulfide instead of iron sulfur. The elements on the left side of the periodic table is used first when naming a compound. Again, the FeS example, iron is on the left side of the periodic table compared to sulfur. So when writing the compound name, we are going to start with iron instead of starting with sulfur. And some transitional metals form more than one cation, and therefore their valency has to be indicated using Roman numerals in brackets after the metal name. As you have seen on the previous cation table, many transitional metals, your iron, your cobalt, your chromium, they had Roman numerals in brackets written after the name of the transitional metal. Like your Fe, your iron, it was iron 2, iron 3, your cobalt, cobalt 2, cobalt 3, etc. So that you will know the valency. You will know if you're working with iron 2 or you're working with iron 3, because these transitional metals, they form more than one cation. So that is it for this video. On the next video, we're going to start talking about polyatomic ions.